Okay, I'll start again. So we added 5 to both sides of this to get the absolute value by itself. Again, we look at this and see that it's positive, means we can go further. If it's a negative number, we stop right there. There's no solution. The absolute value, when it stands alone, has to equal a positive number. It can never equal negative because that's the definition of absolute value is always positive. Okay, once we have this absolute value equaling a positive number, we then break it up into two separate equations. We're going to get two answers, and we must give both answers. X minus 5 equals 8 is one equation. In other words, just drop those absolute values. Our second equation becomes X minus 5, again dropping the absolute value, equaling negative 8. Because what we're saying is the number that was originally inside this absolute value could have been either 8 or negative 8 in order to end up being positive 8 as an absolute value. And then we solve each of these. So I'm adding 5 to both sides here. This gives me X equals 13 as one answer. And adding 5 to both this side gives me X equals negative 3. And my two solutions are the negative 3 and the 13. And if you don't give both solutions, you have not solved this properly. You will not get credit for it because you must have two solutions. Does there anybody have any questions about this at this point?
So when you solve it twice, you make one like the number that is equal to positive, and then for the next equation, you make the number that is equal to negative.
Right, absolutely. That's exactly true. Once you have this alone, you just drop those two bars on the side and then make it into one number being the positive number and one being the negative number. But remember, if this was negative, you couldn't do that because it can't be negative to start out with. It has to be positive to start out with.
So if it was X minus 5 equals negative 8, we couldn't make it a positive.
No, because that's a false statement. The absolute value of something can't be negative 8. Because when you take the absolute value, it's always going to be positive. What could be the number inside the absolute value can be a negative number. But once you put those two lines next to it, like if I ask you, what's the absolute value of negative 13? Your answer would have to be 13. So it can't ever be a negative number. So therefore, when if you see that absolute value equaling to a negative number, you don't go any further. You just say no solution. You're finished with the problem.
Okay, thank you.
Okay. All right. Somebody, one of the students here asked me to go over the whole concept of the number line and how the number line works. And I think that's very important. That's one of the most important things that we learned so far is how to solve an inequality and how to put it on the number line. And also, what's very important is being able to put it in interval notation. So I'm going to put a problem on the board. I'm going to give you some time to do it. This is a review problem as well. And then we'll go over all aspects of figuring out how to graph things on a number line. Good. So I'm gonna give you one that's not a very difficult one, but it'll give us a chance to practice putting things in interval notation and also to putting them on the number line. So what if I gave you this inequality? 3 minus 3x is less than 15. Okay, I'm gonna give you a couple minutes to try it on your own. To come up with the answer, please put it on the chat. And then we'll go over it together and talk about how we do all the things that we need to do with an inequality. I think in the interim, what I'm going to do is I'm going to call attendance. So listen for your name while. Olivia here. Isis. Isis Barco. Alvaro Blake. Louis Cayola. Not doing too well, are we? Emma Charlton. Emma. Demetrius.
Here.
Hi, good morning. Thank you. I'm glad somebody is here. Desmond Fleming. Shania.
I'm here, Shania.
Yeah.
Haley? Yeah, I'm here.
Thank you. I'm glad. Thank you. I did notice, I saw you had asked a question, but I wanted to make sure everybody's hearing me. Caden Ricardo. Caden Harris. Kayla Harris. Kayla, you're here? Okay, thanks. Sanjita Hussain. Oriana.
Miss Weinberg, I just signed in. Isis Barco.
Oh, Isis, you're here? Okay.
Yes.
And Oriana, I see that you're here also. Okay, I put you on for Isis. Thank you. Tahira. Kayla, I know you're here because you were here number 1. Kiana Perez. Kiana.
Here.
Hi. Carleaf. Okay. Hi, Carleaf. Jenna Pierre. Jenna.
I'm right here.
Okay, great.
Hi, hello.
Good morning. Tatiana Sanchez. Naya Sims. Kazandu Small. Trina Small. Jean Thomas. Okay, Olivia, I see you. There's no rhyme or reason as to when I take attendance, so please be aware that it can be any time during the class. Okay, so 1, 2, 3, 4, 5. All right, so let's take this problem and work it through in terms of how we solve it and how we put the answers on the number line, and also how we write the answer in interval notation. Now, if you remember, when it comes to an inequality, you can't just come up with a number. You can't say the answer is 4. That's not how it works. You've got to give your answer as an inequality. And we solve it just like we solve the equation. But we always want to make sure that our x's get left on the left side. Don't, even if it's inconvenient, even if all the x's start out on the right side, you want your x's and your final answer to be on the left side of the inequality and the play number on the right side. So here we're going to subtract 3 from both sides, which will give us negative 3x less than 50 minus 3 is 12. And then what we're going to do is we're going to divide everything by negative 3 because we want to isolate the x. Now, don't forget, here's where you have to be careful. If you end up dividing, we're sometimes multiplying, but mostly what we're doing is dividing. If you're dividing by a negative number, the sense of your inequality, the direction of your inequality has to switch. So the negative 3x divided by negative 3 gives us just the x. The less than becomes a greater than sign. And the 12 divided by negative 3 is negative 4. So number 1, this is our solution written as an inequality. That's the simplest way of writing it. It's the way it's written. after you finish solving it, you've gotten it written as an inequality. The
So
set,
if,
yes,
I was gonna ask, so if it's negative, the inequality switches?
right, when you divide by a negative number, you must switch the inequality. That's that, or if you would, most of the time we're not multiplying, but if you multiply by a negative number, but otherwise you leave the direction of the inequality the same. Only in this case where you're dividing by the negative number, not when you're subtracting, but when you're dividing by the negative number. Is that clear?
Yes, thank you.
Yeah. All right, so now the second thing we're doing is going to our number line. So our number line always is just a horizontal line with some arbitrary point picked as the 0 point. Okay, now going to the right, we're going to have positive numbers. And going to the left, we're going to have our negative numbers. That's how the number line works. Okay, so you look at this number over here and you go to it, which is right here. And the first thing you're going to do, you're going to make a circle there. But sometimes you're going to make an open circle. And sometimes you're going to make a filled-in circle. The difference between an open circle and a filled-in circle is when there's an open circle, it means that really this point is not included. You're just going, that's your starting point, but you're really starting a little bit after it. When it's a filled-in circle, it means that you're including that point as part of your answer. Just as a reminder, if you have a less than, a greater than, or a less than, this becomes an open circle. If you have a greater than or equal to, or a less than or equal to, this is where you fill in your circle. So in this case, are we going to have an open circle or a filled-in circle?
Open.
Open, correct, because it just says greater than, which means the -4 is not included. The next thing we do, okay, so we're leaving this an open circle. And I'll tell you how to do this on Delta Math as soon as I finish this. If you notice, as long as you have the X on the left side of the inequality, this inequality side looks like an arrowhead. And it's actually pointing in the correct direction. This is pointing to the right. That means you're going to, from this open circle, draw an arrow to the right. If it would be a less than sign, it would have been pointing to the left, and it would have been an arrow going to the left. Okay, talking about doing this on Delta Math. If you go to Delta Math and you want to graph it on the number line, what you have to do is click on the -4, hold it down and drag it to the right. And you will see that from -4, there'll be an arrow going to the right. Now, when you click it, it automatically fills in the circle. So if you want the circle to be an open circle and not filled-in circle, after you've drawn your arrow, you have to go back and click on that -4 again, and that'll turn the filled-in circle to an open circle. So the default in Delta Math is going to be a filled-in circle. If you don't want a filled-in circle, you've got to click on it to get it into a open circle. Okay, the third way we can write our solution is what's called interval notation. How do we do interval notation? Well, it's easiest to do it if you're looking at your number line. On your number line, in your interval, you're always going to pick the first point that's on the left. Now, if you notice, this interval is starting right here at the -4, because beyond it, there's nothing. So my interval is going to start to -4. The second number you're going to put in is the last number all the way to the right. Okay, so we're always going from left to right. Notice this is pointing an arrow going on and on, so therefore it's just going on until infinity. So we just write this infinity sign. And then we have to use the enclosures to finish this interval notation. When you have an open circle, you're going to have a parentheses, either an open parentheses or a closed parentheses. When you have a filled in circle, you're going to have a bracket. Now, whether you make it, depending on what side the number is that's filled in. In this case, we're going to be using parentheses because this is an open circle. When it comes to infinity, you never use a bracket with infinity. That always has to be a parenthesis. So here's your answer in interval notation. Is this clearer now? Are we okay with this? Okay, so let's try another example just to make sure we've got it. And it would be nice if people put it on the answer on the chat. I don't see too many people doing that now, and I'd like to see more of that. Okay, so I'm going to erase this problem and I'm going to put in a different problem. I'm leaving this on as a hint. Suppose I give you five minus 2x is greater than or equal to 17. Okay, let's see if you could solve that inequality, put the answer on the number line, and also in interval notation. The easiest way to put it on the chat is obviously an interval notation, except if there's an infinity sign, just write INF or something. Okay, I'm giving you a few minutes to try this. Okay, I see a couple of people that come up with an answer. So let's work on this together. Again, I want to get the x's alone on the left side, the numbers on the right side. So I'm gonna minus 5 from both sides. Which will leave me negative 2x greater than or equal to 17 minus 5, which is 12. And then I have to divide by negative 2. Which gives me x. I divide by the negative number, so it's less than or equal to negative 6. I think we did get that answer as one of the answers. Yes. Okay, Isis, I like your, that was a good idea to use that symbol for the ampersand symbol for these radical, for the infinity sign. That was creative. It's a good idea. Okay. Let's put this on the number line. This is the correct answer as an inequality. Let's put it on the number line. So this was step 1, step 2, here's our number line. And I really like, even if it doesn't ask you to do the number line, it makes writing the interval notation much easier if you do it on the number line. Okay, here's our 0. And here's negative 6. So the question is, do I make a filled-in circle or an open circle? And since this says x is less than or equal to negative 6, that extra little line over here means that we must fill in the circle at negative 6. Negative 6 is included in the solution. Now, which way should my arrow go? So I look at this, look at the arrow, looks like it's pointing to the left. So we have to, from here, draw an arrow to the left. And this is what your answer would look like on the number line. So the next thing is, how do we write this in interval notation? Now, remember, my intervals always go from left to right. The interval here is not starting at negative 6, because that's all the way on the right. The interval is starting all the way over here at negative infinity. So the first thing I have to put is negative infinity. So be very careful. Is it going to positive infinity? Then it has to be going to the right. If it's going to negative infinity, it's all the way at the left, and that's your starting point. A lot of people make that mistake because you tend to think you're starting from here. But no, what we're starting from in the interval is at the left, which is the negative infinity. We're ending our interval here on the right. This is the right note it's going. It's really the interval is going from here to here at negative 6. And since that negative 6 was filled in, we have to make that a bracket to indicate that we have, this is the parentheses and this is the bracket. That indicates that we have it filled in when we have that square parentheses, the bracket. Is this clearer now as to how we do interval notation and how we do graphing on the number line? Or are you okay with it now? Great. I don't remember who it, okay. All right, so I think what I'm going to do now, we have about 50 minutes left, is I'm going to start on the next chapter. Does anybody have a question before I go on? let me remind you what I said at the beginning. We have finished chapter 1. You have, there'll be a 4th homework on Delta Math. There's one that's due for Monday, and there's one that's due for Wednesday. After Monday, Monday is going to be a review day of chapter 1. I'm going to take different types of questions that you might see on a quiz, and we're just going to do them just like we were doing today. These are the type of things you might see. And then your first quiz will be next week. It'll be posted after Monday on Delta Math. It's not going to be an in-class quiz. It's going to be one that you do on your Delta Math at your own time. There will be, of course, there'll be a due date, and there also will be a time limit. So when you start this quiz on Delta Math, you must finish it in one sitting. I'll talk more about it on Monday and give you more particulars, but that's what we have coming up. And that's going to be on solving equations, solving inequalities, and absolute value equations. Basically, those are the topics that we have covered so far, and that's what it's going to include. Our chapter 2, the second chapter that we're going to be talking about, is called Graphing of Linear Equations and Functions. And what we're going to be talking about is basically how do we graph an equation on, not just on a line, but on what we call the coordinate axes, the X and Y axes. I assume most of you have seen this before, but we're going to start from the beginning, and we're going to proceed as if it's a new topic. If if I'm not going into it fully enough, if I'm making any assumptions and you want to just stop me or send me a text or send me a chat. Again, in terms of speaking to me or meeting with me, if you want to have longer than a 15 or 20-minute meeting with me, then you have to make an appointment, and you can do that by emailing me, and we can meet on Zoom on an individual basis. Otherwise, if you have a quick question or something you want to ask me, I usually sign in by 8 o'clock. Class starts at 8:20. So each morning, Monday, Wednesday, Friday, from 8 to 8:20 is a time that you meet me and, so to speak, have an office meeting with me. Again, if you need more time than that, then we can meet on an individual basis. Or if that time is not good for you, just let me know. Sometime next week, we're going to be having an introduction to a master tutor. This course comes with a tutor who has not been available yet. And we will talk about when this person will be available to help with homework, etc., etc. Just as a matter of course, those of you who've been working on the Delta Math, just send me a chat or just speak up. Are you happy with the way that works? Is it working for you? Have you found that you can do the homework on it and you're learning from it? Anybody have any comment? Kayla, you say it's okay, great. For me, it happens to be very good because I can keep track as to where everybody's at. Yes. Okay, is anybody not happy with it for some reason? Okay, so again, it's your responsibility to keep checking after class that there is homework on Delta Math. Would you want me to send out an email when I posted something on Delta Math? Would that be helpful? Or are you constantly checking it? When I assign something on, okay, it would be helpful. Okay, I'll try and do that. Okay, though there's always when I assign something on Delta Math, I usually give it at least a week's time for the due date. Okay, so I will try and remember to do that, to send out, once I post something on Delta Math, I will also send out an email from Blackboard. I'm sending out my emails from Blackboard. If you do not get emails from me, it means that you're not looking at the email that you set up on CUNY Blackboard. If you don't have an email set up there, you've got to have one. If you want to get the emails, that's how they send out a group email from Blackboard. So make sure if you haven't been, I sent one out before each class, but make sure if you're haven't been getting emails from me, you've got to check your Blackboard account and make sure you got the correct information on it. All right, so as I said, we're going to be talking about graphing on not just a line, but on a whole, what we call plane, a whole flat surface. And we do that by having two axes. We have a horizontal axis, which is called the x-axis. And we have a vertical axis, which is called the y-axis. And each point on the plane is assigned two numbers. So one point gets two numbers. It gets a number, the first number that's assigned, it's called an ordered pair of numbers, because the first number always refers to the x or the horizontal distance. The second number always refers to the y or the vertical distance. This is horizontal, this is vertical. Let's just put some numbers here. This is 1, 2, 3, 4, 5. Here's -1, -2, -3, -4, -5. I'm just putting in some numbers so you'll have an idea of what it looks like. When you look at a piece of graph paper, it's going to have, where I have these little tick marks, it's going to have actually lines. A piece of graph paper has lines going not just horizontally, but vertically as well. It's just too much trouble to put all those lines, so I'm just putting in these tick lines. Now, if I write something like this, and I talk about the point -3, 2. And notice I always put them in parentheses. What I'm talking about is a point where this is the directions to get to it. How do you do that? You look at your first number. You always start at this cross point, which is called the origin. And you count from the origin. The first number is the horizontal number. Now, when we know positive is to the right, negative is to the left. So you go 1, 2, 3 to the left. Now you don't put a dot there because there's a second number the number 2, that's telling you your vertical distance. When it's positive, you go up. When it's negative, you go down. So this is from -3, we're going up 2, 1, 2. And this is where your point -3, 2 is located. Notice it's one dot. You don't go here, one dot, and here, one dot. It's one dot represented by 2 numbers, and you need the 2 numbers because it's really those 2 numbers are directions. It's like if you're looking at a map and you want to find a place on a map and it has an A15, let's say, because you need the 2 numbers because you have to go left and right and up and down to get to that number. So the first number is always the horizontal, the second number is always the vertical. If I would tell you I have the point 2, -3, then I would have gone this way. Let me get this out of the way. To get to the point, notice it's the same 2 numbers, but not in the same order. Again, the first number is the horizontal number, the 2, the X, 1, 2 to the right. Negative, then from there go down 3, 1, 2, 3. Here is my point, -2, -3. If I would put a point over here, let's say put this point. Just like if I give you a pair of numbers, an ordered pair of numbers, you can find the point. If I give you a point, you should be able to give me its coordinates, the 2 numbers that go with it. Now, let's see if I have this point. Again, the first number always has to be the horizontal. 1, 2, 3, 4, 5. We're going 5 to the left, going 5 on the x-axis, but it's to the left, so that's going to be a -5. From there, we've gone down 1, 2. It's down 2, so my y is -2. So this point is the point -5, -2. So we have this correspondence where we can, number 1, if I give you the coordinates or the numbers of the point, and you'll know their coordinates because you'll have 2 numbers inside of parentheses, you can find the point. And if I give you the point, you should be able to give me the coordinates, the numbers that go with it. All right. I think everybody is pretty much in tune with that. Everybody knows how to put points on the graph. The next step after that is to take an equation of a line and write the equation, write the line that I'm giving you the equation of. So I'm going to erase all these points that I put in. and I'm gonna talk about how do we graph lines. This is linear, this is called graphing of linear equations. And the key word in the word linear is line, because a linear equation, when you graph it on the coordinate system, will give you a straight line. Now, because we have two variables here, we have an x and a y, when we're going to be writing equations of lines, we're going to be having two variables in our equation. I could have an equation that looks like this: 2x plus 3y equals 6. This is an example of a linear equation. Notice I'm using the term linear equation, and I used it before even though I haven't graphed it yet. How do I know that an equation is a linear equation? Because I look at the exponents that are on the x and the y, on the variables. Remember, I don't see any exponent here. This is just a plain x, this is just a plain y. But just like when there's no number in front of a variable, it means the coefficient is 1. When there's no exponent, there's no little number up here, it's understood that the exponent is 1. This has an exponent of 1, this has an exponent of 1. When we have just exponents of 1, then we have a linear equation. Now, an equation that has only an exponent of 1 is called a first degree. The degree is the exponent. The exponent, the highest exponent we have here is 1. It's a first degree equation. The term first degree equation and the term linear equation mean the same thing. In other words, when we talk about a linear equation, we know that we're looking at an equation that doesn't have any exponents. If I were giving you an equation that looked like this, y equals 3x squared plus 2x minus 5, for example, this is not a linear equation because the x happens to have an exponent of 2. It happens as soon as there's an exponent other than 1, which means if you see an exponent, then you know that you do not have a linear equation. So it's really easy to recognize that what we're dealing with is a linear equation. So we're erasing this because it's not linear, we're not up to it. A little later in the term, or towards the end of the term, we will actually talk about graphing equations that have exponents. But that we'll get to it when that comes about. So the question is, how do I go from an equation like 2x plus 3y equals 6 to the line? I told you it's a linear equation, so it must represent a line. How do I find the line? Now remember, we're talking about a straight line. How many points would you need to figure out a line? Well, if you think about it, as soon as you have 2 points, that right away determines where the line is going. A straight line only needs 2 points for you to draw it. If you want to draw a curvy figure, you need a lot more than 2 points. But with a straight line, as soon as you have 2 points, you've got your line drawn. You could just go higher and lower, but you could extend it either way, but it just keeps going. The direction is set with 2 points. So the question is, if I want to find the the line that goes with the equation, what we have to do is find some points on the line. And we do that, there are a couple of different ways we can do that. The first way we're going to do is something called plot points. Okay, I'm starting with this equation, 2x plus 3y equals 6. I want to find at least 2 points on that line. Remember, the only reason I only need 2 points because then I can just connect the 2 points and I have my line. So what makes a point to be on a line? How do I check? Well, that's where the equation comes in. In order for a point to be on the line, the coordinates, the x and y numbers of the point have to make the equation a correct equation. So I could ask you this question. Is -4, 7 on the line? How do we check? We take the -4 and replace the x with it. We put, because that's the first number is the x coordinate. We take the 7 and replace it in the y. And we see if what comes out is a true statement. So here's our check. Two times -4, replacing my x by the -4, plus 3 times 7. Let's see what that works out to be. Is -8 plus 21, which is 13. Okay. When I plugged in the -4 for the x and the 7 for the y, I got 13. Is the point on the line? Obviously, no. Because I didn't get the right answer. The answer I was supposed to get was 6. This turned out to be 13, and 13 does not equal 6. So that point is not on the line. What about the point? 0, 2. Is that point on the line? Okay, I'm going to give you a minute to try that. Check to see if the point 0, 2 is on that line. Anybody have an answer? Okay, let's check if 0, 2 is on the line. So here's our equation that we started out with, 2x plus 3y equals 6. In place of the 2, of the x, I'm gonna put 0. In place of the y, I'm putting 2. And this is gonna give me 2 times 0 is 0 plus 6, which equals 6. It checked, which means the point 0, 2 is on the line. Well, where's our point 0, 2? Here's my x is 0. So I'm not going left or right on that. Here is a point on the line. So if I gave you a bunch of different points and asked you to see if a point is on a line or not, you don't even have to look at the line itself. All you have to do is look at the equation. Stick the numbers into the equation. If the equation works, the point is on the line. If the equation doesn't work, like with -4, 7, the point is not on the line. Okay, so that's if I were giving you points. But what if you on your own wanted to find points? So let's go to the next step. How can I find points on my own to put on the graph? So here's what we can do. Pick any number you want for x. Let's say pick x to be suppose I pick x to be -3. I'm just picking any number. Suppose I pick any number for x that I want. I'm making actually a chart of values. So let's do it this way. Let's say pick x to be -3. Stick that -3 into the equation and solve for y. 2 times -3 plus 3y equals 6. This gives us -6 plus 3y equals 6. It's a regular equation to solve. I'm adding 6 to both sides. This gives me 3y equals 12. And when I solve for y, I get y equals 4. In other words, another point on this line is -3, 4. There are millions and millions and millions of points on a line. Endless, an infinite number of points. What you have to do is just find 2 of them. We already had one from before. We had this point 0, 2 that we figured we had checked. We now know that another point on the line is a point -3, 4. Well, let's go over there. 1, 2, 3 to the left, because it's -3. 1, 2, 3, 4. Here is another point on the line. Okay, actually, I could draw my line now because I already have 2 points. But let's try and find another point. Let's pick the easy one. Let's pick x to be, no, we did that one already. That one we already have. Let's pick x to be pick -3, let's pick +3. Okay. Let's go over here. If x is 3, how do I find the y? So I'm going to go over here. 2 times 3. I'm replacing my x by 3. Plus 3y equals 6. Again, I can pick a value for x and find out the corresponding value for y. So this is 6 plus 3y equals 6. I'll subtract the 6 from both sides. This will give me 3y equals 0. And 0 divided by 3 is 0. So the corresponding value for x being 3 is y being 0. Here is another point on our line. 1, 2, 3. I'm just erasing this because I think it's easier now to see. If you notice, my points all line up. Here is my line. Notice the line goes, I put arrows on the end of the line because it keeps going to further and further to the right, further and further to the left. But it's all, you notice, again, it would have been enough just to have 2 points. But the third point is actually a check that we've done our work correctly. This is a method of called plotting points. If you want to graph a line, one way to do it is to plot points. It happens to be a pretty, I won't say complicated, it's not so much complicated, just takes a lot of time. Plotting points is not the easiest way to find the graph of the line. Let me show you one other method that we could use. And we'll do this exact question using that other method. You're going to see that we're going to basically find the same line. So again, here we're starting with our equation. 2x plus 3y equals 6. And what we're going to now find, instead of plotting points, we're going to find the intercepts of the line. If you look at this line that I drew, it happened to be, this point was just sort of out there in space. But this point, 0, 2, was a point on the y-axis. The point where it crosses the y-axis is the point 0, 2. This is called the y-intercept. And this point was a point on the x-axis. This is what's called the x-intercept. Sometimes we use, say, the y-intercept is 2. I don't even have to put in the 0, because if I'm talking about the y-intercept, I'm talking about where the line is crossing the y-axis, and it means it's 2 up. So saying The y-intercept is 2 means that you're going on the y-axis up 2. It's understood when you're talking about a y-intercept that the x has to be 0, because in order to be on the y-axis, you can't be to the left or right. You have to be on the 0 for the x. Similarly, the x-intercept. Sometimes we don't say the x-intercept is 3, 0. We just say that the x-intercept is 3, because that means you're going 3 along the x-axis. It is understood that the y value would have to be 0, because if you're on the x-axis, you're not going up, you're not going down, you're just going across. So this line happens to have a y-intercept of 2 and an x-intercept of 3. How do we find the intercepts from the equation of the line? If we could find the x-intercept and the y-intercept of the line, then it would be relatively easy to draw the line. All you'd have to do is connect those 2 points. So here's the rule. To find the y-intercept, replace x in your equation with 0. And vice versa, to find the x-intercept, replace your y with 0. Because in order to be on the y-axis, your x has to be 0. To be on the x-axis, your y has to be 0. So here, we take our original equation, we're finding the y-intercept, we're going to replace x with 0. That will give me 2 times 0 plus 3y equals 6. Well, 2 times 0 is 0, so this is just 0 plus 3y, which is 3y. And if I divide both sides by 3, I get my y equals to 2. The y-intercept is 2. I'm redrawing it over here. To say that the y-intercept is 2 is telling us on the y-axis, you're going up 2. To write it as a point, you'd have to write it 0, 2, because a point always needs an x and a y. The x has to be 0, the y is 2. That's 1 point. Let's find the x-intercept. To find the x-intercept, I'm going to take my original equation and replace the y with 0. So I'll get 2x plus 3 times 0 equals 6. Again, 3 times 0 is 0, so this just becomes 2x equals 6. And that gives me x equals 3. My x-intercept is 3, which means that what we're talking about is a point that is 3 units on the x-axis right here, also written as 3, 0. The x-intercept always has its y being 0. The y-intercept always has its x equal to 0. Now notice I have 2 points, so now I can just draw the line. Notice it's exactly the same line. It's much easier to find the intercepts and use that to draw the line than just to find random points. So method number 1 was plot points. Method number 2, which I think was a little bit more efficient, was to find the specific points that are the x and y intercepts, because those are the easy points to find. To find your x-intercept, you put your y to 0. To find your y-intercept, you put your x equal to 0. It's one method of solving finding the equation of the line, finding the line, give it the equation. Next time, after we review for the quiz, but next time, we're going to talk about a third method of finding the graph of a line if we're given its equation. Okay, I think I'm going to stop now. Does anybody have any questions they wanted to ask me? Let me just make sure that I have everybody's turned in. 1, 2, 3. Okay, so I have everybody. I have all 13 people. Have a good weekend. And don't forget to check Delta Math. If you haven't done anything on Delta Math yet, you must check it. Make sure you signed up for Delta Math and that you have done the homeworks. By Monday, there will have been 3 homeworks that you have to have done. Okay, anybody want to talk to me after class? You can leave me a message. All right, if not, have a nice weekend. Hope the weather should be nice. And I'll see you Monday morning.